All right. So we were talking about C++ programming. So let me. So I did some some homework. Okay, so C++ OP concepts. Okay, so last class I was talking about classes, structs, classes, private access modifiers. And so there was a question, what is the difference between struct and class? So the thing is that all elements of struct are public unless specified otherwise. That means that if I have a struct A, and then if I say int A char C, and let's say string S, then all of them are public. Are public by default. Public by default. On the other hand, if I just do the same thing, if I instead of struct, if I have a class, there should be a column here. If I have a class B, then all of them are private by default. That's the only difference. Okay. Okay. And so if I want something else to be, if I want some data members or method members to be of other default, other access type, then I should specify either using other access modifiers are three kinds: public, private, protected. Okay. So what is the meaning of public? Public means that any method from any class or any object or any class can call they access this member or call this function. Yeah, I hope that is clear to everybody. Yeah, that's the meaning of public. So that means that if I have let's imagine if I have I can access. So if I have int main, from within int main, I can call b dot a. If I have, let's say I have an object of type b, so bb. Now if I say bb, b is an object of type b. And if I want to access b dot x, b dot a equal to 10, not a problem, since a is a public member of B. Okay, on the other hand, if I have, let's imagine if I have a private member here, I have private. So how do I get something private? I just write private colon. And if I say int x, now b dot x equal to 15 is problematic, not allowed, since x is a private. Okay, and similar is the case with methods in a class. So all the public methods I can access, Private members, I cannot. Public members, anybody can call. Private methods, only the class objects
Sir,
themselves.
B is a class here.
Pardon?
Sir, B is a class here.
B is an object of this class, capital B. Sorry, I should have chosen a better name. Which
Sir,
what?
but these A, C, and S in class B, they are private by default.
They are private by default. Sorry, I should. Yeah, they are private by default. My mistake. So B dot A. Let me. I should have put it. I should have put public here. Sorry. Thanks for pointing that out. Index. Yeah. Now everything is fine. Everything is fine now.
Yes, sir.
All right. Okay. And here you can also have protected. The meaning of protected comes when you, and this is the idea of encapsulation. Okay. So whatever we discussed so far, the the packaging of data and related methods is called encapsulation. Okay, encapsulation, or sometimes it's called data encapsulation, but yeah, that's the idea. So basically, you have you aggregate all the data and methods which act on those data on one place and package them as one object. That's called encapsulation. And this is one of the main ideas of object-oriented programming. That means you bring together all the associated data and the methods together. Okay, and that is called data encapsulation. And then this, if I have a method here, I should let me come on here. If I have a method here, let's say assign, let's say IG, assign A. Okay. So if I say B dot assign A of 15, okay, assign value to private member A. Okay, so this is one method in which I can assign values to private method A. And why I decided on this example is because sometimes this is seen as sending message assign A to method to object B. Okay. So when Smalltalk originated, Smalltalk is the first object-oriented programming language, object-oriented programming language. Yeah. And so the paradigm of object-oriented programming introduced by Smalltalk was this: that everything is an object, and you send messages to objects. Okay, so for instance, calling this method B, calling this method assign A of the method of the class of the object B is actually seen as sending a message assign A to object B. So objects actually call each other's, send messages to each other. So basically what they are doing is that an object, you send a message to object. That is how you see calling a method. Is that, does it make sense what I'm saying? Hello? What I said?
Yes, sir.
No. Okay, so that is idea. Okay. So we already discussed one major idea of object-oriented programming, encapsulation. The other major idea, so there are three major ideas. It is one of the three major ideas. The other two are inheritance and polymorphism. Okay. Yeah. So inheritance is what we are going to see next. So not all. Yeah. Yeah. So most programming languages has all these three: encapsulation, inheritance, polymorphism. For instance, take Java or Python or anything. There are all three ideas. But encapsulation is not a it's not universal. For instance, in Haskell, there is no notion of encapsulation, but there is inheritance as well as polymorphism. Today we'll get some time to look at those. Okay, so what is inheritance? So imagine I have a class base, and this class has X. Okay, and so it's a private member. Now, if I have a class derived, I'm just calling it derived. And what I can have is, so let me have three kinds of members here. I have a private member, which is X. Then I have a public member, which is Y. And I have a protected member, which is Z. Okay. So I have three kinds of members in my base class. Now I'm going to define a new class, derived, which I can derive from the base class using either base class okay, derive one. So let me do it three ways. I can derive two, derive three. Okay, so from the base class, I am deriving three classes. One I am deriving as public, or the other I am deriving as private, and the other I am deriving as protected. Okay. Now, so this is where I was stuck last time. So I'm deriving from my base class, I'm deriving three classes: derive one, derive two, derive three. And in derive one, I am deriving my base class as private. In derive two, I'm deriving my base class as public. And in derive three, I'm deriving my base class as protected. Now, what is the meaning of these three things? So this means that what does it mean to derive a class privately? Derive from a class privately. It means that all the private members of base class are not derived. All the public members of base class of the base class. of the base class becomes private members of the derived class and all the protected members also. The base class becomes private members. Okay. So basically, when I derive from the base class, if when I derive as private, what it means is that all the members, so all the private members are not derived because these members are not derived. But so now what will happen if I have, let's say, let me get rid of this info. Let me. So if I have an int main here, and if I have an object derived 1d1 and derived 2d2 and derived 3d3, and if I have, now what happens is that if I look at d1 dot y, it cannot be, there is an element called d1 dot y in d1, but it is a private member, so I cannot access it. Okay, but there is no element called d1 dot x because d1 has base class as a member called x, but it is a private member of base class, so they are not inherited. Okay, is it clear what I'm saying? Hello?
Yes, sir. I think it's clear.
Yeah. Okay, so d1 dot x, no such member d2 dot x, d1 dot y, d1 dot z are private members of d1. Okay. Now, so therefore, can you extrapolate this idea? What will happen if I derive publicly from the base class? Can somebody guesstimate? What will happen if I derive publicly from the derived class, publicly from the base class?
Sir, the private members of the base class will not be derived, whereas
Okay.
the other members would be derived and would be made as public in the derived class.
No,
Almost.
sir.
Yeah.
Public public remains public and protected remains protected.
Exactly. Okay, that is the case. All the private members are not derived. Public members are derived as public members. Protected members are derived as protected. Okay, so basically what happens is that if you have an access modifier in the base class, its access modifier does not expand. It remains. So this private, public, protected are actually giving an upper bound to the access modifiers of the base class. So if it is private, everything has to remain as private. So the private cannot be derived, so they are not derived. Public and protected, they have to be restricted to private. On the other hand, if it is the case of public, the upper bound is public, so private remains private, they are not derived. Public remains public. Protected cannot go above protected, so they remain protected. Okay. I hope it is clear. And so if we go by the same rule, derived in the case of protected, private members are not derived. Public members are derived as protected members, and the protected members are derived as protected members. Okay. So that's the idea. That is how you derive from one class. Now, if you ask me, is there some, is it very useful? I mean, I don't find it very useful, but because there might be scenarios in which it might be useful, so that from the base class, when you derive a class, its access modifier can be modified. There could be scenarios where it is useful, but I think it is a choice of the language designers. So they found it I don't know why they chose it to be so. I can't. I mean, it's C++ is not a Spartan language like C. It has lots of bells and whistles. So I think this is another one of those cases. I mean, it's not, C++ is one of the most complicated languages out there. So okay, so that is what is how you inherit. Now, if I have I could actually derive from multiple classes. Okay, so yeah, so let's draw a diagram. So if I have a base class A, and we will write this A B means that A derives from the base class. So that is how you write. For instance, for example, in our case, derived 1 implies base, okay, in base class. Also derived 2. Derived 2 and derived 3. So from the same base class, you have 3 classes derived. You could also have it in this. You could also have A, B. So here what happens is that derived 1, derived 2, derived 3, arrow base. We could also have A, arrow B, C. Okay. This is called multiple inheritance. Okay, this is called multiple inheritance. For in our case, for instance, I could have a class derived, let's say, derived mul derive. class mul derived, and I put a colon there, and then I say public derive 1, derive 2, public or private derive 3. Okay, in which case the class mul derived inherits from two classes. Okay. Now this kind of inheritance is problematic. Okay. For instance, Java does not allow it. For instance, Java does not allow such inheritance. Okay. Now, what is the problem? The problem is this. Okay, so here I have, let's imagine, yeah. So what could be the problem here? Why we discourage multiple inheritance? Any guess?
So because it would be tough to decide the accesses that needs to be given to the variables which are present in derived 2 and derived 3, because in them only the accesses are different.
I didn't understand what you just said. The access is not a problem. We are saying that derived 2 is public and derived 3 is private. Okay, so that's not a problem. That is given clearly.
Sir, but derived 2 and derived 3 are derived from a base.
Yeah.
And so they have the non-private members of base, but the accesses in those are also different, right?
Sir, if drive 2 and
Yeah.
drive 3 have a variable with same name.
Yeah, if you have the same name, then they will be overridden. So you cannot predict what will happen, which one will be derived. So in the order it will be taken. Okay, so the order is important. The order in which you derive classes is important. So for instance, if you have a method here which is derived from, which is present in both, then the first one will be chosen. You understand what I'm saying? If I have a method here in mul derived, which is inherited from the class derived 2 and derived 3, from both places it is coming, then if I want to resolve which function to call, I will first look at the derived 2. If the method is present there, that will be called.
And its access would be public.
Its access will be public.
Okay.
Okay. Now, I don't know the case in which there is if it is private, probably it's my wild guess. I haven't verified it. If this is private and this is public and there are two methods, and then this cannot be called, so probably it will go and call this one. Okay. I don't know. That you have to check. So many edge cases. Anyway, so the problem with multiple inheritance is something called diamond problem. Diamond problem. Okay, so the diamond problem is, so in this case, if you look at, we have the same base class from which we are deriving both derive 1 and derive 2 and derive 3. Okay, and then from the class multiple derive, we are deriving from derive 2 and derive 3. So what will happen is that same base class is derived twice via these inheritance. So for instance, if I have a constructor function here for this multiple derived class, whenever that constructor function is called, um, so what will happen is that when you create the object for multiple derived, it will call the constructor. You might choose to call the constructor for derived 2 and derived 3. Okay, that will call the base class twice. Okay, for instance, if I have, let's imagine I have a public constructor function called base. Base constructor. Okay, so there is one base constructor class. Okay, so similarly, let's imagine public derived one, and let's imagine I have the same constructor here also, derived 2 constructor, and derived. I just added constructor function everywhere. Okay. Now let's make a object of type mul derived. Mul derived m. Okay. And now if I compile C++, there are a million errors. Undeclared identifier value. Okay, so now let's see what happens. So I am just making an object of type mul derived. Now that calls base constructor. So before the mul derived constructor is called, it calls first the base constructor, then the derived 2 constructor, then the base constructor, then the mul derived 2 constructor. So okay. All right. So if I want to, when I'm trying to make an object for mul derived m, what happens is that it first creates an object of type mul derived. To create an object of type mul derived, it has to contain, it is an object of type derived 2 as well as of type derived 3. So first I make an object of type derived 2. So for that I will create, this one will be called derived 2, but that will call the base constructor, the constructor of the base class. So first it will come base constructor, then it will call derived 2, then it will again call base constructor, then it will call derived 3 constructor, then it will call mul derived constructor. Okay, so Ideally, there should be only one base constructor, because ideally we are only creating one object, but ultimately what happens is that there are two base objects, two objects of the type base class has been created. That is what is called the diamond problem. Okay. Now, I cheated a little. What I cheated is this, that when I create an object of type M, it automatically call all the base constructors of the base classes. Ideally, if the constructor is an empty constructor, only then it will go call everybody. Okay. If it had a value like int x, then I have to, the compiler will throw an error. Compiler will tell me that you have to specify which constructors of the previous classes have to be called. I have to specify it exactly. Yeah, that's what I have done here. Okay, so here I have classes A1, A2, A3, A4. So A1 is just a class. I mean, none of them have any elements. It's just A1 has a constructor which takes an integer value, and it will output A1's constructor is called. So similarly, A2 derives from A1, A3 derives from A1. So A1, A2, A3. So it's already like I'm trying to create a triangle, a diamond, A1, A2, A3, A4. Yeah. So A2 derives from A1, A3 derives from A1, A4 derives from A2 as well as A3. So we have a diamond like this, A1, A2, A3. Okay. So, but if my constructor is not empty, like here, all the constructors are taking an integer value, then I have to specify which of the constructors have to be called. That I have to do by colon followed by the prior constructors. Okay. So A2, I say A2 int x, I have to call A1 x and then execute this call. This is called initialization. Okay. You can read about it. It's not it's ugly, but yeah. And A3 also, if I have if it takes an integer, so therefore I have to specify which of the prior base classes constructors have to be called. So I say A1 of x. Similarly, A4 of x, I say A2 of x and A3 of x. Now, what will happen is that when I initialize an object of type A4 of 1 of x of 1, okay, I'm creating an object of type A4 and I'm calling its constructor O of 1. So I'm giving A4 the value 1. Then it will call A2 of x and A3 of x. A3 of x will call A1 of x. A2 of x also will call A1 of x. So A1 of x will be called twice. That is called the diamond problem. Okay. So one object of A4 will contain two copies of the base constructor. Ideally, it should contain only one object of every prior classes. That is the diamond problem. Now, there are workarounds for the diamond problem, but again, many programming language designers don't see the point of having such complicated things. So, for instance, Java, there is no way you can derive from multiple classes. That you can only derive from one class. Okay. All right. So that is the idea. That are the So so if you allow this kind of this is multiple inheritance. Now you can also have multi-level inheritance. You can have here you have base class, derive 1, derive 2, which derive 1, derive 2, derive 3, all three from base. And if I want to create multi-derived, if I just say for derive 2 and let's say base class, let me have a new class here, class multi-level. And if I say public,
it's 11 o'clock.
Derive 1 and public base Okay. This is an example of multi-level inheritance. Okay, because it's the same class. From base class comes derive one, and derive comes derive one, and class multi-level I'm inheriting from both derive one and base class. Again, there might be some strange situations where you might need such derivations, but it's but most programming languages don't allow such trickeries. All right. So that's the basic idea behind inheritance and the problems and the related problems. So the idea is very simple. Keep it simple, like in Java. Okay. So this is the idea called inheritance. So we already looked at encapsulation and we looked at inheritance. Now the third major idea.
Sir,
Yeah.
does this inheritance work similarly in the case of a struct as well?
Yeah. So there is no difference between struct and class, except that struct everything is private, struct everything is public, and yeah, it should work the same. And if you ask me, you should look at, for this kind of questions, you should look at the language standard. So every language will have a published standard. Okay. So C++ will have 20 different compilers. There is Borland C++, there is Apple C++, there is GNU C++, and so on. So there will be different compilers. They will all agree only on the published language standard. Okay. And on others, they will define their own, what they find convenient for them. So checking in one compiler is not enough, because it might happen that in the particular compiler you are checking, it might be that way. But I checked for the struct and this one. This is the only difference which is they said. That struct is class, which has all these members as public. And class is where all its members are by default private. Now, the other differences, each compiler might choose to implement in their own way. So we can be sure unless we check it in the language standard. So C++ language standard. Okay, so this is the ISO C++ standard. Now, if you go here and if we look at struct, okay. Okay, so here there is something called what is a class, what is encapsulation. Yeah, what is the difference between keyword, struct, and class? The members of the base and base class of struct and are public by default, while in class they default to private. No, you should make your base classes explicitly private, public, or protected rather than relying on the defaults. So they are also saying that. Okay, struct and classes are otherwise functionally equivalent. Enough of that squeaky clean techno talk. Emotionally, most developers make strong distinction between a class and a struct. A struct simply feels like an open pile of bits with very little in the way of encapsulation functionality. A class feels like a living and responsible member of society with intelligent services, strong encapsulation barrier, and a well-defined interface. Since that's a connotation most people already have, you should probably use the struct keyword if you have a class that has very few methods and has public data. Such things do exist in well-designed systems, but otherwise you should probably use the class keyword. Yeah, that's what it says. So functionally they are equivalent. That means that whatever works, you could Control C, Control V struct everywhere. Yeah. Okay. All right. Now I should. I don't think today I'll get time to talk about the major idea called polymorphism. Okay. So what is polymorphism? I think so far whatever we talked about, encapsulation and inheritance. Encapsulation is a strong object-oriented concept. Packing everything together. That's the idea behind encapsulation. And inheritance is not particularly object-oriented idea. It can exist in other programming languages also. And polymorphism as well. What is polymorphism? Poly means many, and morphism means morph means, or morph means. Okay, so polymorphism. So polymorphism, many shapes. Okay, so what is this idea? Let me pull out my, what is this? GHCI. This is Haskell compiler. Okay. Now, if I in Haskell, this is a list 1.10. Like in Python, if I say 1.10 is the list 1 to 10. Okay. Now, if I say head, so there is no brackets. So if I say head dot 10, it will tell me the first element of the list 1.10. Okay. And if I ask what is the type of 1.10, it will tell me it is a num type for any. It actually, let's ask what is the type of one. Says that for any numeric type P, one is of type 1, type P. Okay, so that means that what is P? P is a type variable. So for instance, it could be int, it could be double, it could be float, it could be fractional, and so on. So there are many numeric types. So it says that one is not a particular type. It could be a constant from any of the numeric types. That's what it says. And what is head? What is the type of head? Type of head is if you have any type or of the form box A, then okay, so that means if you give me any list type A of type box A, head will output a type A. So that means if you give me a list of integers, A will be int, and head will be a function from list of integers to integer. If it is a list of characters, it will be list of characters to a character. Yeah, everybody understood this one? That means that head is not of one particular type. For any, you give me list of any kinds, I can, head is of a type which takes a list of something and give me something. Okay, so that is the idea behind polymorphism. That means that your method is not particularly um, it's not fixed to be one type, but how do I say it? One second. Um, so my function head can take list of any types. Okay, list which contains any type, and it will out, and let's call that type A. Okay, so A could be int, A could be char, A could be strings, and so on. But you give me any list of type A elements, it will output me a type A element. That's what head means. So the same idea we are going to see. So basically what it says that the type of my head, the function called head, which essentially outputs the first element of a list, is not particularly fixed for a list of particular type, but for any list it will work. Okay, so that means that according to the necessity of the situation, head can be of different types. That's the idea behind polymorphism. Okay, now let's see what is polymorphism in the case of C++. Maybe I'll take it in the next class because already today there is not much time. So what is polymorphism in the case of C++? So basically there are polymorphism uh, can be divided into two kinds of things. One is compile time or static polymorphism. Polymorphism or static polymorphism. The other is runtime polymorphism. Okay. So compile time polymorphism are again of two types. For instance, example function for overloading, operator overloading. They are both the same type of operator overloading. Okay, so for instance, I could have an operator called plus. Depending upon what comes, like if it is 2 plus 5, then the compiler will interpret 2 plus 4 as one thing. And if I have two types of objects called complex numbers, then depending upon what are the arguments given to this plus, compiler will choose what is the definition of plus to be chosen. That is what is compile time polymorphism. Runtime polymorphism is dynamic binding. Okay, that means that what function to choose to run yeah. So we'll look at dynamic binding in the next class. Okay, and by next Monday onwards we'll start our presentations. Hello, have you guys started discussing? Hello.
So we'll start, sir, so soon, like today.
Okay.
Today onwards. Yes, sir.
All right. Okay then. Thank you.
Thank you, sir.
Okay. Bye.
Thank you, sir.